Constant rule, derivative of a constant is 0. Power rule, derivative of x power n is nx power n minus 1, right?
Yeah.
So feel free to stop me when we come to something that you feel you've never studied before. Cool. And then constant multiple rule along with a function, d by dx of a constant times a function, you can bring out the constant and then take the derivative of the function itself. So d by dx of c times f of x is c times f prime of x. Okay. Sum and difference rules. So if you have two functions f of x and g of x, which are differentiable on a certain interval, then d by dx of f of x plus g of x is f prime of x plus g prime of x. Same thing for subtraction. D by dx of f of x minus g of x is f prime of x minus g prime. Okay. And then derivative of sine and cosine. Derivative of a sine function is cosine x, and derivative of cosine function is negative sine x. Okay. And then, okay, do you remember until here?
I think I forgot a little bit what derivatives, if we can go back.
Okay. Okay, all right. Let's start over again. I think that's better because it is important. You can start off with a notebook, fresh set of notes, yeah, whatever works for you. It's good to keep making notes because going back to the textbook will be a lengthier way to revise stuff. Okay.
Yeah.
So ready with your notebook? Can I start? Let's start from basic differentiation once again. Hello?
Yeah, I'm here.
Okay. All right. So make a note of this. You don't have to know proofs for each of these theorems, unnecessary. But if you do like to know them, you could just take this as an exercise at your end. The proofs are there in the textbook. You can look at them and see how by using limits we derive all of these differentiation rules. Now, let me start off by talking about why we need these differentiation rules in the first place. Now, up until now, if you were asked to find the derivative of a function, what you would do is you would use the limit technique, right? F of x plus delta x minus f of x divided by delta x, where you would take the limit of this, wherein delta x would approach 0. Is that right? Do you remember that much?
Yeah.
Now, when the function becomes complicated, naturally, finding out the derivative using that process would be really, really cumbersome. So in order to overcome that problem, different mathematicians over a period of 150 years have figured out certain rules that you can apply directly on a function to figure out its derivatives. Now, what we will study about are those rules. And eventually, once we finish studying these rules, we won't use the limit way of finding out the derivative until and unless it has been specifically asked to do so. With that context, let's get started. Starting off with constant rule. The constant rule states that the derivative of a constant, that is d by dx of 2, 3, 4, 5, any number, the derivative of a constant function is equal to 0. Okay. So you have some examples here. Y equal to 7, so dy by dx is 0. F of x equal to 0, so f prime of x is equal to 0. S dash of s of t is negative 3, and therefore s prime of t is 0. Y equals k times pi square, where k is a constant, pi is a constant, therefore y prime is equal to 0. Any doubts so far?
No, that makes sense.
Okay. Next, we move to power rule. What does power rule state? Power rule states that if n is a rational number and your function is of the form x bar n, then it's differentiable and the derivative is this d by dx of x bar n equals n x bar n minus 1. So d by dx of x bar 3, for instance, would be 3x squared. Clear?
Mm-hmm.
And d by dx of x, therefore, would be 1. There are some examples here. So x cube derivative will be 3x squared. Cube root of x, I can rewrite this as x power 1 over 3, right? So your derivative will become 1/3 x power negative 2 over 3, which is as good as writing 1/3 1 over 3 times x bar 2 over 3. And the same thing applies to y equals 1 over x squared. It can be rewritten as x bar minus 2. And then you go ahead and apply the power rule. Okay, now I want you to work on example 3. You're supposed to find the slope of this graph where the function itself is x bar 4 at 3 different points. And I hope you remember this. When someone asks you to find the slope of a graph, you have to figure out the derivative and then substitute the point at which you're trying to find the slope. Try this out.
A, right?
All three.
Okay. Okay, so x. Next it's -1. Hmm. Mm, I'm confused. I'm not sure.
Okay, so let's do the first one together.
Oh, wait. It'd be -4.
Correct. Yeah, because your derivative is 4x cubed, and then you substitute x equals -1, therefore it'll be -4. Okay, what about B and C?
It's 0.
B is 0, okay,
And C is 1.
correct. So you applied the power rule here. Next, this is another kind of question. Find the equation of the tangent line to the graph of this function when x is -2. We have done a similar question in limits. Now do the same thing, but this time derivative is found out using differentiation rules. Go ahead, try this out.
Hmm. I'm not really sure.
Okay. Now forget about the differentiation rule. Can you tell me what you did when you were asked to find the tangent line earlier?
Mm, you look at the original function.
Okay, and
So you would do f -2, which is negative, or -2 squared, which is 4.
Okay. So you have a point, -2 comma 4. All right.
Yeah, but then that's when I get. Okay, then.
And then what else do you need for tangent line? You would need the slope, right?
Yeah.
How do you find the slope?
Oh, you got the derivative of f,
Exactly. Mm-hmm.
which is f prime x.
Okay. What is that here?
That will be 2x.
Correct. And when you substitute x equals -2, that
Oh,
becomes.
okay. Yeah. Then it becomes -4.
So now you have slope, you have a point. Can you frame the equation?
Yeah. I forgot the equation. 1 minus 4 is equal to. Okay. Yeah.
Right? That's your general form, that when you have a point x1 comma y1 and you have the slope m, your point slope form is going to look like this: y minus y1 equals m times x minus x1. Okay.
Okay.
So I will leave it here. Some teachers are okay with leaving it like this. Some teachers would want you to simplify this to get it to the form y equals mx plus c. Okay. So
Yeah.
depending on what your teacher expects, you can simplify it further or just leave it in this form. Okay.
Mm-hmm.
Any questions so far?
No, I understand
No.
this one.
Okay. The only thing that we used to do differently earlier was this portion of figuring out the derivative. We used to do that using limits. Okay.
Mm-hmm.
Okay. Sanchez, another thing that I would want you to do before I continue is if you find some time today before the next class, just go back and revise everything that we have done in limits, okay? Because I'm going to keep referring to it and then talking about future topics, okay? So it'll be good to just go back and brush through the topics that we learned before you went on a vacation. Would that be possible for you?
Yeah. Okay.
Okay, all right. Let's continue. Okay, so that was about equation of a tangent line. Now let's learn another rule. The other rule is the third one, fourth one rather, is the constant multiple rule. The constant multiple rule states that if there is a function which is differentiable and c is a real number, and your function is of the form c times f of x, and if you're asked to find the derivative, then d by dx of c times f of x, you can separate out the number and then just find the derivative of the function itself. So if I have to give you an example, if I were to tell you find the derivative of 4x square, for instance. Now here, this is f of x and 4 is c, right? Now what I would do is, to find the derivative of this, I would separate out the 4, then take the derivative of, or d by dx of x square alone. Okay? Now what is d by dx of x square? That is going to be 2x, right? I've taken out the 4. So 4 times 2 is 8. 8x becomes your final answer. Does that make sense?
Yeah.
Okay, so that's called the constant multiple rule. There are quite a few problems here. Okay, so the next rule is the sum and difference rule. It states that if you have two differentiable functions, f of x and g of x, and you want to find the derivative of either their sum or their difference, it's as good as splitting it and finding their derivatives individually. So d by dx of f of x plus g of x is f dash of x plus g dash of x, and d by dx of f of x minus g of x is f dash of x minus g dash of x. Okay, so the first one was the sum rule, the second one is the difference rule. Does that make sense?
Yeah.
Okay, some examples here. Go ahead, try it out.
I'm confused how to do this one.
Okay, no problem. We can do it together. So let's do part question A together. So you have x cubed minus 4x plus 5. Now this is as good as three different functions being together, separated by either a minus sign or a plus sign, right? Now, whenever you're trying to find the derivative of such a polynomial, all you have to do is you find the derivative of each of the terms separately. So f prime of x will be derivative of x cubed, which is 3x squared, and then minus derivative of 4x, which is just 4, right? Plus derivative of 5, which is 0. So your final answer will become 3x squared minus 4. Does that make sense?
Yeah.
Okay, go ahead, try out part B.
Okay. All right. This makes more sense. Negative 2x cubed plus 9x squared minus 2.
Correct. Part C.
Um, 3 or 2? Is it 2?
No, so whenever you're given such a question, it is a good idea to just simplify the question first, then find the derivative. Okay, by
Okay.
simplify, I mean 3x square minus x plus 1 can be written as 3x minus 1 plus 1 over x, and then find the derivative. That makes your life a lot simpler.
All right. Okay. Oh, I got a different end. So I got 3x squared minus 1 over x squared
3x square.
minus 1 over x squared.
Uh, how did you get a 3x square?
Well, that's in the, it's the first coefficient of the function,
Okay.
but I simplified after I got 3 minus 1 over x squared. I made the denominator x squared, so I multiplied.
Oh, you're talking about a common denominator. Oh, okay. That makes
Yeah.
sense. All right, okay. I was wondering where you got a square from. Got it. All right, makes sense. 3x squared minus 1 over x squared. That's correct.
Yeah.
Okay. Um, yeah. The next theorem is derivative of trigonometric functions. We'll study only about sine and cosine now, and there's a dedicated chapter where we'll study a little more about these special functions.